of ATP. We kind of already did this. We went to the internet. But I'll do it again for you. So if you can't see, tell me. If you can't see the thing. Okay. All right, here's a little sugar. Here's a phosphate group. And here's a nitrogen-containing base. I call it a nitrogenous base. What's the little sugar here? Do you remember, Colton? Yep. Just a little 5-carbon sugar, right? 5 carbons. Just a little sugar. All right. So let's simplify our formula. You have a sugar, a phosphate, and a nitrogen-containing base. What kind of monomer did I just draw? What kind of monomer is this?
Nucleotide.
Good. It's a nucleotide. ATP happens to be a nucleotide, a modified nucleotide. How is it modified?
Don't they have like one something? I forgot. Doesn't it have a 3 pHs by any chance?
Yes. That's one of the modifications. Let's simplify it a little bit. It could be AMP. It could be ADP, 2 P's. It could be ATP, 3 P's. I'm putting these are not S's, these are squiggly lines. Okay, sugar, the carbon, one of the carbons in the sugar is bonded to a phosphate, which also makes 4 bonds, and carbon makes 4 bonds, so that's a really good, strong covalent bond. There's good energy in that bond. It's going to hold on to that P like nobody's business. But then, when you connect a phosphate to another phosphate, they are really strongly bonded, so this bond is really strong. And this bond is even stronger, because now you got a phosphate bonded to a phosphate bonded to a phosphate. So the squiggly lines represent, and in particular we're going to focus on this one here, high energy phosphate bonds. So you might remember from A and P that ATP is the universal energy molecule. You'll see that on your test. By that I mean all living things must convert energy, however they got it, eating fancy feast, breaking down decaying trees, whatever. All living things must convert energy from their food into ATP. And ATP is what the living body uses as energy. So if you can't convert your food into ATP, and some forms of diabetes are just that. They don't have the right enzyme to run a Krebs cycle. So their metabolism is kind of screwed up. They can't extract energy efficiently from their food. So everybody uses ATP. My cat's got to make ATP, bacteria got to make ATP, fungi got to make ATP, we all got to make ATP. Do viruses make ATP?
No, they're not living.
Viruses are not considered living by traditional biologists because they don't make ATP, they don't have a metabolism. If you come upon your friend one day and your friend is laying on the ground and you take their pulse and there's no pulse and you feel their body and it feels cold, there's no body heat, what are you thinking? There's no metabolism happening here. You must be dead. If you're not metabolizing, you're either frozen or you're dead. And pretty much frozen is dead. At least nowadays. Technology might find a way to freeze you and bring you back to life, but right now I don't think it's really possible. Although some people do, because they have themselves frozen, or at least their head.
Exactly. Brain.
I'm like, really? If you have that much freaking money, that you can pay to have your head frozen, you got way too much money. Way too much money.
But how are they gonna resurrect?
I wonder what they did with Michael Jackson. They never talk about that. They might not have actually buried him. They might have like done the whole funeral thing, just that then maybe they froze him somewhere.
Yeah, but he was already dead before he was frozen.
Yeah, he was. But they might have still frozen him, thinking they could bring him back someday. Because he would have enough money for that.
Like
If they haven't had a cure for death, we're all out of work.
What?
If they haven't had a cure for death, we're all out of work. What do they need nurses for?
Yeah, that's true. I don't think you'd want to live forever.
No.
Because
I think
trust
the
me,
population
the
would be
time you
a
even
huge
get to
issue.
my age, you're like, I can't take it anymore.
That's
I just, you know,
done.
and my grandma used to say before she died, the whole world's gone to shit. When you feel that way, it's time to go.
Yep.
And that's when you check out. When it's like, you know what, I can't deal anymore. Or else, like my aunt, she's 92 years old, has no idea what's going on. And I think it's probably a good thing.
Yeah.
Because she would not be able to deal, you know?
My great grandma made 105 and a half because she thought she was 12.
Oh, that's a good strategy.
She was very happy.
Yeah, she was
never
happy.
used a wheelchair, never sick, just happy. But she thought she was 12.
Life's a strange thing. All right, so your modified nucleotide, it's a sugar with a phosphate, but can have additional phosphates. So that's one of the modifications. Can have additional phosphates, ADP, ATP. And the other modification is this right here. The nitrogenous base is always A. It's never C or T or G, it's always A. So ATP is modified in two ways. Extra phosphates with high energy phosphate bond, and always adenine. Now, this part of the molecule, the sugar in the adenine, is adenosine. That's what you call the part of the molecule that's the sugar with the base. And in fact, this part of the molecule is called the nucleoside. So I know some of you saw on your test nucleoside and nucleotide and you thought it was a typo. Think of it this way. The nucleoside is the side of the nucleotide. So there is such a thing as a nucleoside. It's this area of the nucleotide. The whole thing is the nucleotide. If it's the sugar, phosphate, and a nitrogen-containing base, this is a nucleotide. Right? This part is the nucleoside. So the part without the phosphate is the nucleoside. Once you put the phosphate on it, it's a nucleotide. You're like, really? Really? All you really need to know is if there's no metabolism, your patient's dead.
Good.
Okay.
Do we need to know all those formulas?
You need to know a nucleotide, yeah. And you're going to need to know DNA. But we'll make it easy.
Yeah.
Okay,
Sounds like
now, let's talk about that energy conversion prep. Okay? I call it, I think I have a slide for that. I call it the ADP, ATP, or ATP, ADP recycle. It's actually called the ATP, ADP cycle, but I call it the recycle, because look, it's recycling, right? You take your complex molecules, you can break them down, you get energy out of it. This would be your catabolism, what I was trying to draw on the board before. You got your simple molecules, you can build them up into proteins or DNA, that's your anabolism, but you're going to have to put energy in to the reaction. Where are you going to get the energy from? You're going to break your ATP into ADP in a loose phosphate. When you break this bond, when you break that bond right there and the P comes off, you're down to ADP, but the energy from that bond is released to do work. If you ate extra Snickers and you have energy to store, when you break down your food, you can take the energy from the food and build that bond back and add a phosphate to it and store the energy. So ATP is the storage form of energy. Where's the energy? For the most part, right there. When I break that bond, I release energy. I use the energy for anabolism. If I do catabolism and I want to store energy for use later, then I create that bond and store the energy in that bond by adding another P to it. Okay? I call that slapping a P on.
So,
You want to store some energy? Slap a P on. Because
So-
when it attaches, the energy gets stored in that bond.
okay, so ADP plus phosphate group equals to ADP, in which equal.
Right. So when you're, gosh, I need a pointer so bad. But the problem with pointers is the batteries. Oh, I know, I'll use this. Okay. ATP, I have ATP, why? Because I ate food, I broke it down, energy from the bonds in the food is available. I take the energy from the food, I create a phosphate bond and make ATP.
So that's gonna be a simple molecule then. Because I don't get the why are these simple molecules down.
Oh, over here. Because
Yeah.
if I break my food, if I digest my food, I break it from a complex apple into glucose. So I'm breaking down my complex molecules into my simple molecules.
In which-
When I do that, energy is released,
Okay.
and the energy is used to add this P to ADP and store it as ATP.
Okay, so energy.
Then when I want to build, I have to break this P off, I'm back to ADP and a loose P, but I can use that energy to build the simple molecules into a complex molecule.
So you release energy by adding ATP